What's going on, guys? Let's do this problem right here. The first question is asking a point charge q is located a short distance from a point charge 3q and no other charges are present. If the electrical force on q is F, what is the electrical force on 3q? So what's going to happen is since q the q's electrical force is F, the 3q is going to have electrical force in the opposite direction but same magnitude. So it's according to the it's according to the Newton's third law, right? Every action has equal and opposite reaction. So that's what we are going to apply right here. So since Q has electrical force of F, the 3Q is going to be having electrical force of negative F, but it's a opposite direction, but the magnitude is same. So the answer for this one is going to be just F. It's also going to have the force of F. And let's do the second part. So the answer for the first one is F. So let's do the second part. Two identical small charge spheres are certain distance apart, and each initially experiences an electrostatic force of magnitude of F due to the other with time. With time, the charge gradually diminishes on both spheres. When each of the spheres has lost half of its initial charge, the magnitude of the electrostatic force will be what? So that's the question. So initially we are having F is equal to KQ1 Q2 over R square. So R square, right? So when in this situation the force is equal to F. So what's going to happen if the charges are going to be half? So let's see what happens. So what we have to do is we simply divide the forces by, the electric charges by 2. So Q1 by 2, Q2 by 2 divided by R square. So if you notice that this is going to be KQ1 Q2 over 4R square, right? And this value is equal to F right here. F, right? So this is going to be 1 over 4F. This is equal to 1 over 4F. And that is the second answer. And the right answer for this one is D. And that's how we do this kind of problems. I hope you guys find this helpful. Thank you for watching.